Okay guys, in this part of 4.3, we're going to talk about the corresponding logarithmic rules that go with the associated exponent rules, and then see how they apply to equations. To the product rule, that is, if two numbers are multiplied inside a logarithm, they can be separated into their own logarithms of the same base and added. Division turns into subtraction, similarly. If you have the power rule, power to a power you multiply. If you have a number raised to a power inside a logarithm, you can bring that power in front of the logarithm and it's a coefficient now. And then the more common ones, anything to the 0 power is 1. For logarithms, that's log base a of 1 equals 0. That's just a rewritten form. You can see how that works. And then anything to the first power is itself. And that means the logarithm, if the base and the inside of the logarithm match, it reduces to 1. So let's see how this applies in some equations. Log base 6 of 7 times 9, multiplication inside a logarithm can become two separate logarithms added together. Now really 9 is 3 squared. What that allows us to do is bring the 2 up front. And so this is how expanding works. You want everything to be in its own logarithm, preferably to the first power, so nothing squared, without taking the powers up and put them in coefficients. Let's look at number 2 as well. Division becomes subtraction. Log base 9 of x squared minus log base 9 of y to the 4th. And both of these have exponents that can come down front. 2 times the log base 9 of x minus 4 times the log base 9 of y. So relatively simple, all things considered. We'll do one more. Number 3. So one key strategy here is that anything in the numerator will end up positive, anything in the denominator will end up negative. So what that means is this could be log base a, the square root of mnq, minus log base a of p squared z to the 4th. You have to make sure to distribute this negative when you split them here. And this will all be positive. So log base a square root of m plus log base a square root of n plus log base a square root of q minus log base a p squared minus log base a z to the 4th. So everything from the denominator ended up with a negative in front, which is important. Of course, the square root power is to the 1/2 power, so I can bring it technically a 1/2 in front. 1/2 log base a of m plus 1/2 log base a of n plus 1/2 log base a of q minus 2 log base a of p minus 4 log base a of z. And now all these variables are by themselves, so we're done with this. Okay, so if you can expand them, you can also condense them into one logarithm using the rules going backwards. So what we have here is addition can actually be multiplication inside a logarithm. So log base 3 of x plus 2 times x minus log base 3 of 2. Subtraction can become division. Log base 3, I'm going to distribute the x. This is x squared plus 2x divided by 2. And once everything's in a logarithm, you can clean up the inside, but really you're done from there. For number 2, log base b of m, when you put the powers back in, it's log base b of square root of m plus log base b of 2n cubed, the square root of that, minus log base b of m squared n. So when I combine these, this is log base b of 2 cubed is 8. This is really 2n cubed. So it's 8n cubed. So this is the square root of 8n cubed m minus log base b of m squared n. I actually think I prefer it as a fractional power. Log base b of, this is really 2 root 2 m to the 1/2 n to the 3/2. Subtraction becomes division over m squared n. From here we can use our power rules to clean up. M to the 1/2 divided by m squared is m to the negative 3/2. N to the 3/2 divided by n is n to the 1/2. So show you all how you want to look at it there. You could turn this as well into log base b of 2 root 2 n to the 1/2 over m to the 3/2. Honestly, I'd be happy if you get it even here, but your homework will want you to simplify it as much as possible, so be aware that that's a thing that happens. Lastly, we can apply this to actual numbers. Sometimes your homework will give you certain values and they expect you to break it down to get the rest of your values. So we'll talk through a few of these. Log base 10 of 4, of course, log base 10 of 4 is log base 10 of 2 squared, which allows you to bring 2 in front. 2 times the log base 10 of 2. Since the problem told you the log base 10 of 2 is 0.3010, this is 2 times 0.3010, which is 0.6020. So your goal is to break down these numbers into the components they gave you. Now, log base 10 of 5. In your head, you might be thinking, well, 5 is 2 plus 3. However, the logarithms only break down if you have multiplication on the inside. So you're like, how do I get 5 from this 2 and 3? The one thing that they will never tell you, because they assume that you know, is that log base 10 of 10 equals 1. Remember, if the inside of the logarithm and the base match, it's 1. So this log base 10 of 5 is really the log base 10 of 10 divided by 2. And of course, division allows us to turn it into subtraction. Log base 10 of 10 minus log base 10 of 2. So this is 1 minus that 0.3010, which is 0.6990. So let's see, we'll do one more. Let's do log base 10 of 40 over 81. So this is log base 10 of 40 minus log base 10 of 81. And we know 81 is 3 to the 4th. And 40 is 4 times 10. So this is the log base 10 of 4 plus the log base 10 of 10 minus 4 times the log base 10 of 3. Log base 10 of 4, we know from part 1, we could convert it again, but it's 0.6020. Log base 10 of 10 is 1 minus 4 times log base 10 of 3 says it's 0.4771. So this is 1.6020 minus 4 times 0.4771. 0.4771 times 4 is 0.9542, 1.9084. When you subtract those two, you get negative 0.3064. Generally speaking, logarithms that are, when the inside is less than 1, your logarithm will be negative. When it's greater than 1, it will be positive. So that's a good check for what's happening. 40/81 is smaller than 1, so we're expecting a negative outcome. And that's really all for 4.3, these logarithm rules. It's really a practice thing. And that's it for this week.